Hi there all. Today's test is a galvanic cell, a copper and zinc cell. The two solutions we have here is copper sulphate that has 47.882 grams of copper sulphate to 300 mils of distilled water. That one mixes up quite well. It doesn't drop out a solution as easy as the zinc. And the zinc is 48.441 grams for 300 mils for 1 molar solution. But this has been sitting in here for a while and it just keeps dropping out of solution. So I stirred it up and poured it into the split tub cell. We have the copper sulphate on the right side and zinc sulphate on the left side, separated with a 4-ply cellulose acetate membrane. And I bought a heap of new alligator clips because the old ones get consumed pretty quickly, so I'm going to use the dummy clips on the end, which can be consumed and chucked away when they degrade. That will be the copper plate size and the zinc cell size. They're pretty identical in size. And what we're testing for is we're going to put it on the 30 milliamp load. And we're going to see how that performs with no carbon on any of the electrodes. These will be the dummy ones, an extra separation from the good leads. Alright, so we'll turn the meters on. Okay. Got the copper one set up. Okay, right, we're reading 1.09 volts. We're normally 1 volt up on that. I'll get the load. Oh, I should connect that down here. Alright, that's got the load connected. We're 1.0 there and 1.088 on that one. Okay, alright, we're ready for our first load test on a galvanic cell. Does it work? Ah, yay, what's going on? Oh, could be the membrane's not too great. But we dropped right off. I'll change the voltage. Well, I would have thought that would have worked. Maybe need a better salt bridge. Test number 2. Alright, we're holding at 0.047 volts. Could be too big a voltage drop between the 4-ply membrane. The 2-ply one I accidentally broke a couple of weeks back. Now, I'm not sure of this. Oh no, we're not even doing the right milliamps. It's only 0.13, 13 milliamps. Well, that's disappointing. Anyway, I made up a another carbon chip, a bit bigger. It's got a bit of a hole in it down there though, but I'm going to compare it. The other one's sort of plated in copper a bit. See? That was still going pretty well. So the little galvanic cell's not that great. It's 1 molar solution each. We've had that cell running better with aluminium cells, and also a nickel cell I think was performing a bit better. Well, we'll turn off that logger, data logger, because that doesn't seem to be supporting that, and we'll put the multimeter on and run it through the load. The motor. Can you see the motor? There it is, just there. Alright, connecting. Alright, we only get 10 milliamps. 11.6 and a 0.0. Well, it is sort of working. Oh, you can't see the meters. There we go, 11 milliamps and 0.23 volts. Not these connectors. Alright, we'll stop that. We'll put some power through it and see what happens. Connect that one up. Where's the power supply? Alright, applying 10 seconds worth of 2 volts. Might have it hooked up wrong. Oh yeah, I think it is 1 and 2 and 3. I think that was charging 20 milliamps. Oh, actually no, that was a short circuit. I need the power supply lead. Ah, here we go again. Ah, that looks a bit better. Well, that's 10 seconds. Let's see if we get anything out of the motor. somewhat a little bit higher, but we don't get motor startage. We'll increase the voltage, see if we can penetrate that membrane. We'll go to 5 volts. And that's 10 seconds. And we'll try the load. So we do get it starts it now by itself. It's still only drawing well, okay, we'll get rid of the zinc cell, I mean the copper one. And we'll try the original cell first, see what we get. This should tell us if there's something strange with the membrane. Okay, voltage is still the same. Yeah, we'll check the load. 13 milliamps, but we don't get motor startage. We'll try 5 volts in it on a 10-second charge. Well, that was 20 seconds. Voltage is somewhat a little bit high. Trying the load. Still nothing. Needs a flick. Drops right back down to 0.2. Could very well be that membrane's too thick. Okay. Just check something. We'll put the copper one back in the zinc sulphate solution with the other one. Come on, they want to touch. Alright, checking the load in the same solution. Oh, that's much better. The membrane is playing a part in stopping it. So we got 27 milliamps, 0.5 volts. Quick 10-second charge. Went off the scale. Alright, 10-second charge. Run and load. 50 milliamps. Motor's actually making a noise. Alright, so that's the zinc sulphate. Let's try copper sulphate. Okay, copper sulphate cell doesn't have, oh, better connect it. Bit low on the voltage. Oh, it's going up. No. Alright, running the load. 42, 38 milliamps, so it does run the load there. Somewhat higher. Charging. And that's about 10. Voltage dropped pretty badly. It's only 0.8. Yeah, it's holding, oh, it's dropping still, so it's leaking. And for a load, only 40 milliamps. Seems to be stronger over there in the zinc sulphate. Back with the zinc sulphate. I won't attach it there, I'll see if I can put it in closer. So we get higher voltage through there. We're at 1 now, but we don't have a load. Or do we? No, we only get 10 milliamps through the separator. It's a little bit too hot to make a new separator. They're drying too quickly. For now, I'll make one later when it cools down. Well, we're still working, but we're not drawing a lot of power. 12 milliamps and 0.29. Well, I think my galvanic cell failed. I thought it was going to do a lot better than that. I even thought it was going to run the load data logger for a while. But we need a better salt bridge. Alright, I'll conduct another experiment when I get a new salt bridge of 2-ply. 2-ply ones are pretty hard to work with, but I think I can let it dry out because this one's been sitting here for ages. And it seems to be stable now. Just need a bigger one. It's quite thin and very hard to keep it flat. Alright, thanks for watching. Oh, hang on, we could make a salt bridge. Oh no, I don't have another sulphate. Alright, don't worry. Alright, thanks for watching. Okay, I thought of another test. This is a test of what happens when we mix 2 sulfates in one container. Okay, they're both equal mass in molar weight. The zinc plate also has gone extremely black from just that little test we had. See the coating? It's quite thick. Compared, we've done better tests for longer and had less coating. Okay, we're at 0.9 with the combined electrolyte. We're doing a load test on the motor. We've got 31 milliamps. Ooh. Alright, we'll give it a 10-second charge at 5. Oh, we'll drop the voltage down. We'll go back to 2. Alright, it's on about 2 on the analog meter, connecting. And that's around about 20 seconds. We're still low on the voltage. Checking a short circuit. 90 milliamps in there holding. Ah, that looks good. Running the load. Well, that's a bit better than the other cells setup. Pretty sure I had that going alright before. Could be blocked up. There's some discoloring from the nickel and zinc. Or was it nickel and copper? One of the two. Or the nickel and an iron cell. So the pores might be blocked up. There's yellow stuff dried onto it. This thing's going not too bad. We might be able to do a load test. I reckon. I'll load it up. Alright, we'll disconnect that first. Connect the load. Okay, setting the parameters. Okay, initial voltage 0.9, and 30 milliamp load, and cutoff voltage 0.22 starting. Oh. Alright, starting. I think I had to reset that list. Alright, we dropped right off. We're doing our 30 milliamps now. The meter says 0.69 volts and we're 0.7 holding steady. After this test we'll do a half-hour charge test on 2 volts. Alright, I'll let this run and I'll get back. Just a quick update. Check out that power curve. It's been 36 minutes. It dropped right down to around about 0.5 volts and then it shot up. It's shooting up because the zinc plate there is growing. Look how fluffy it's got with copper. It's sucking the copper out of the solution and probably the plate because the solution's getting less green somewhat. So we'll see after this runs out. Oh, it's just gone to 6 volts. 0.6 volts. It's going up. Alright, I'll get back in a minute. quick update. It's the craziest looking power curve. It's on its decline now, as you can sort of see the remainders of the green solution is dissolving onto the zinc plate over here, which has gotten quite thick and fluffy. Some bubbles pop out of that and the whole thing wobbles. I'm actually surprised it's got this far, but let's see what happens when we add a charge to see if it's reversible. I don't think it is. And there might be a cut-off time for charging, as you don't want to, and also a rundown on load for voltage. The lower we go there, maybe the plate is getting consumed beyond the point of repair. There's a definite watercolor change from the above the waterline to under. But I'll run it down to 0.42, I reckon, instead of the 2.2. But we'll keep the 2.2 there just in case I miss it, and the graphs will be the same size. Alright, I'll be back. Okay, we're cutting it off at 1 hour 16 at 0.43 volts. It's starting to drop really quickly anyway, but we got 23 milliwatt hours out of it and 38 milliamp hours. Alright, I'll set up, we'll do a charge curve and see what's going on with that for its first charge. I'll set that up and I'll be back. Okay, we're going to start a power curve for this test. We're on 2 volts on the analog, connecting the power now. We got 2.3 on this, starting the monitor. Oops, it was started. Alright, we're sort of flatlined here. Oh, I haven't got it connected. Okay. Oops. Alright, there we go. Got some milliamps going in. Forgot to attach the other lead from the load tester to the negative. Okay, that's strange looking. We're at 269 milliamps, not dropping. Alright, the cell currently looks like this. About that green. Alright, I'll get back in about a half hour. Back not long. It's only been 3 minutes. This big surge in milliamps was due to the copper plate lifted up and touched the other copper plate, so I poked it down with the tweezers, and it's not looking good for a recharge. Maybe if all that copper was in the carbon, it would hold and bond and split, but in that state, I'm not sure what's going to happen. I don't think we've gotten greener, but it's hard to say, it's only early, 4 minutes. It could be getting greener. Alright, I'll get back. Hopefully that piece of copper doesn't float up and hit the other cell again. Hi there, it's been an hour. The graph's all over the place. The copper lifted up again and separated and earthed out on the copper plate. So I pushed it sort of behind the plate and down on the bottom. And I'm not sure if it's actually getting darker in colour. So we're going to do another hour's charge with the scope hooked up to see if we can see anything going on. If I can get a clear enough picture with that scope. And we'll see what happens then. One thing I noticed, if you touch all the copper at the bottom of that cell, see all those bubbles? They're all trapped under the copper solution. Alright, I'll set everything up and be back. Okay, we're back. The time lapse didn't quite work. The camera ran out of memory, so we've only got to a charge of an hour and 40 minutes. So it's been charging for an hour and 40 minutes and there's nothing sort of happening. We got about half hour of time lapse or something, maybe 15 minutes. But the copper electrode is starting to be consumed, so we currently got 123 milliamps and 1.88 volts, and on the data logger we have 1.6 volts. So I'll disconnect the charge. And we dropped pretty quickly. I don't know how well this is going to go. So here goes, 30 milliamp load. Now, no. $30 milliamp load now. The tub may have gone a little bit greener, but I'm not sure. Definitely the bottom part of the copper electrode has been consumed. There will be no copper left to plate on there, I don't think. Alright, I'll let that run and we'll see what sort of power curve we get. Well, we're back. This cell's life's over. It's 0.4 volts and run time is only 21 minutes and 6 milliwatt hours or 11 milliamp hours. And somewhat dissolved a bit at the bottom. And a massive build-up of copper down along that one. The zinc plate looks pretty healthy still. We'll examine the solution. Just disconnect the device. Okay. Okay, looking at the copper cell. Somewhat, pretty much dissolved. I think it was round about there. So that's the copper one and the zinc one. Zinc one has some build up, some decay, and maybe some thinning. That build up's quite thick there. And inside we have a thing of bubbles. I think we have a lot of copper. Well, that one seemed not to last long. It's already destroyed and we've only given it 2 hours charge, pretty much, and that's it. Alright, I'll post all the charts at the end of the video, and thanks for watching the failed galvanic cell test.